of the somewhat small group of individuals that enjoy footage of antique or vintage or older emergency vehicle lighting, I'm sure there's a smaller group that enjoy a technical analysis of a specific product line and an attempt to return a specific model to its factory configuration. So if you're here looking for some strobe footage, there is some, but we're mostly going to really explore the Dash Master series, specifically the version called Deck Master. There were a lot of versions, but what we're doing is trying to restore a Deck Master system, which is two Dash Master 2s linked together with separate power supplies, but synchronized. So we're trying to restore two separate units into this system. So this is going to be a technical video about that. And by we, I mean myself and another individual listed at the end of the video. The Dash Master 2 came out in 1987. So did the Dash Master, but the 2 was the dual head unit, 2 strobes. It did have options, a single head cutoff, a 3-wire plug, a power, a ground, and a kill 1 light. And that's pretty much how that was marketed. The Dash Flasher came out 1987-ish as well. It had similar models as well as steady burn ones. Austin Electronics, the Amber division, kind of at that time, picked up the product line as well. Different model numbers, but same thing. And later Gauls took it over. But the Deck Master specifically was 2 Dash Master 2s linked together to form a system. And with that system, you would have a switch that would turn on all 4 strobes synchronized or 2 strobes synchronized. So up would be all 4 and down would be just 2, but they would be synchronized while retaining their own power supplies. This particular system was described in 1988 as sold as a system or able to be made by simply buying a second factory Dash Master and getting the cable, and you could connect them on your own. That would mean that in order to get this synchronized effect, all you would need to do is buy a second Dash Master 2 and the cable kit, and you would have that. They specifically say this, and that would mean that they would have to be identical, and they would both have to have the second plug and the internal wiring for synchronization. It just sounds expensive. So in 1987, it came out. It was listed as new, and the Deck Master was part of that listing. And it was described kind of as we just described it. It was continued in 1989 and 90. They no longer really talked about being able to build your own. It was sold as a system. There really wasn't any verbiage about building your own system by buying a cable anymore by then. In 1992, the Deck Master, the 2 linked together, isn't even listed anymore. It's not offered. You were essentially down to the 2 strobe or the 1 strobe, the 2 halogen or 1 halogen option. In 1995, the Dash Miser, or headlighter at the time, started to replace it. And then Gauls picked up the product line as Street Lightning. So Gauls never had a second plug for synchronization. They never sold it with that plug included as their brand. They sold the hybrid board version, which included a dummy plug, and I do not believe the hybrid board actually affords us any options to synchronize. So the later versions, rebranded by Gauls, were hybrid boards, and there was no Deck Master by that point. A Gauls version is going to have the hybrid board with newer Minimax or Micromax strobe beams, and these were manufactured, at least under the Galls brand, into the year around the year 2000. So 1995-ish, 96, Whelen stopped having it in their catalogs, and Galls picked it up. My most recent example is a Galls Street Lightning from 1998. So these were offered for a decent amount of time as a rebrand. But even in the beginning, when they sold it as the Whelen product, I don't believe Galls offered the Deckmaster or any cable kit or any mention that you could make a Deckmaster, at least on the Galls end. When talking about the later versions, I've used the term hybrid board. It's like the one below, with a purpose-built chip, but still containing some off-the-shelf electronic components like the one on the top. It does not have separate timing circuits or the little neon lamp to illuminate, but it does still contain some what you would consider standard electronics components. It hasn't gone completely purpose-built yet. So it's called hybrid because it has a little bit of both technologies. The Whelen Edge was the same way. So that's what that term means, and the Galls version was almost always hybrid, as were the later Whelen versions. So what did you get with a regular Dashmaster 2? In this case, the later model, but it doesn't matter. What you definitely got was the ability to cut off one strobe and just flash half the unit. And that was accomplished by the third wire in the plug. However, the Galls version, while this did function, their plug assembly did not contain that wire. So you would have had to add that wire to do the cutoff. Theirs was more of a cigarette plug, standalone, buy it and use it version. But it still had that functionality even in the later hybrid board and in the Galls version. We're going to need to cover clipping. And by that, I don't mean the first-person shooter video game walking through walls. I mean the energy level at which the charging is cut off and the tubes fire. The little potentiometer on the early and hybrid boards, while it could be used to adjust the flash rate, that's not really what it was for. It determined when at what energy level the primary capacitors released their energy. So it determines the energy level the tubes receive. It also protects the device from overcharging. Why would you need to adjust that? Well, there's minor differences in electrical components, and so you can make sure things are within spec and get the exact right amount of energy. And that is pretty important with strobe power supplies, both from a longevity and from a specifications point of view. So yeah, it can change the flash rate, more so in some versions than others. It's a factor in the tube firing, so it can change it, but that's not its specific design or purpose, and there are trade-offs to adjusting it. In the case of the Dashmaster, this one's a hybrid board. In the case of this one, it adjusts the rate significantly. It cuts off when the energy is enough energy, but we're looking for a target of right around 30 watts, and changing the clipping is going to change that. The faster we go, the lower the watts, because really what we're doing is we're turning down the threshold at which the tube's going to fire. So we're getting less energy delivered to the strobe tube, but we're getting it delivered faster. On the opposite side of things, if we turn the opposite direction, there's a point, if we go past it, that we've waited so long to just charge the tube that we're coming close to a failure state, and we also release less energy. So there is a sweet spot, and Whelen supplies come tuned to the sweet spot. And there's actually usually they take a soldering iron and they melt a little line in the potentiometer's dial into its housing at the sweet spot. So you've probably seen some hacks before. I know there's one on YouTube about adjusting the flash rate of your dash master, and really you're adjusting the clipping. So you're making it dimmer but faster. It's still cool, but that's what you're doing. This has been true of Whelen strobes for a long time. This is a single flash commander power supply, and it is essentially second generation Whelen power supply, so it's very, very early supply. And I'm adjusting the clipping and I'm adjusting the rate, but I'm also greatly adjusting the brightness, and there's a really, really small sweet spot with this one. And these supplies were riveted shut, so if something started to go bad, your flash rate and brightness just were all over. So what do we have? We have two dash masters that are from a very similar time, and we're going to try to turn them into a deck master, which is the 4 total head unit, 2 dash masters combined. That's what the project is. According to Whelen, you can upgrade to the deck master simply by buying another dash master. Well, why would we do that? Because we want to synchronize them. As you can see here, the bottom one is synchronized, red, white. The top 2 are individuals and not synchronized. How important is synchronizing lighting? That depends. Like any good answer about any emergency service question, the answer, of course, is it depends. But on the far spectrum of asynchronous lighting, you have just a blurry, disgusting color mess that you really can't make out, and it becomes pink if it's red and white, it becomes purple if it's red and blue. So you need some distinction, and in order to do that, you need to synchronize. So if you synchronize two dash masters into a deck master, you could flash the blues against the reds, and you would avoid that asynchronous kind of hard for the eye to see effect. Now, on the other end of the argument, there is some truth to, I believe it was a California Highway Patrol study that found that regular, very repetitive flash patterns actually could draw people in like a moth to a flame. As humans, we crave patterns. We look for patterns everywhere. It's how our vision works. We're trying to find patterns, and we like them. So there is an aspect of having a random flash being beneficial. So really, there's a satisfaction side of synchronizing flashes, and then there is a truth in color or trueness of color side of synchronizing flashes. So the reason to synchronize your 2 dash masters into a deck master should be to keep your colors separated or flashed on the phase that you want them so that they can be distinguished. But maybe it's just a matter of your own personal satisfaction. Either way, synchronization might be better, or lack thereof, may be better shown with these halogen models. It's one top, one bottom. So you've got the top 2 and the bottom 2 lamps are synchronized with each other, but not the top and bottom unit are not synchronized in that fashion. So your top 2 lamps and your bottom 2 lamps are your sets. If you could achieve both blues flashing at the same time, it might make this signal set a little bit more well defined. And there is a way very easily to synchronize halogen versions of this light. It's much simpler. In fact, it just involves removing the brains from one and having it become a slave to the other. So really all you're doing is making a dummy light and powering it from the other one, which is not interesting or fun, which is why that project wasn't undertaken. But this does kind of show you why you might want to synchronize your strobe dash master into a strobe deck master, or why not doing it and having two units might not work out as well. You could argue that if you kept them on opposite sides of the dash, like the literature states you should, or deck, like the literature would state you would do, it might not be that big a deal. It might not be. I mean, but again, the visibility, depending on the colors and the color combination, synchronizing the two units could be very important. So what we set out to do with the project was to fulfill the statement that Whelen had made, that you could take, when they came out, any two dash masters, hook them together, and by having the proper cable, you had yourself a deck master. So I had a 1987 and 88 models. One had no plug on the back at all, and the 1987 model did have the plug, and therefore should be good to go. The one that didn't have the plug didn't even have the dummy plug left. So, and that's what the sync plug should look like. So that kind of left us wondering, and then we look, and I realized that I don't even think the later one is in the correct housing. The original housing was squared, later housings weren't. We made the cable, and ended up figuring out that it wasn't going to be like colors to like colors. There was a lot of reverse engineering involved, and there's a lot of differences between the base model and the sync model, but it really comes down to the connection of the four wires and each wire's components that are next to it, which are essentially either a smoothing capacitor or resistor, diode, something for handling what that wire does, and that wire is acting on the timing circuit of the device, which is a 555 timing chips. So we tried to figure out exactly how it actually worked and then replicate it. So I got out my I took the two of them apart, and I got my sync one, my non-sync one, and I got out my best pile of recycled and tested as good components, and set about the task of making these two identical, because the literature said all you needed was two base model dash masters, and you could make yourself a deck master with the proper cable. The switch wouldn't really be super important in this. It would be more important to use the cutoff feature. You would want the cutoffs, I would assume, to cut off two of the four lamps, so you would have to marry the cutoff wires into the switch, and the way that switch was wired was up was all four lights, middle was off, down was two lights. So the wiring of that was no mystery. The wiring of the synchronization cable itself is what gave a little bit of trouble. So went about putting together the two matching units, and this is what we end up with. We've got two essentially identical synchronizable units. So anybody that has seen me test strobe stuff, I use these later model 2000 era PAR strobes. Right now the two power supplies are not hooked together. I'm just getting a baseline. I'm using par 36 on each one. The strobe tube inside each of these is very similar to the original bulbs. So now we'll hook up the sync wires, and we will get a look at whether or not this just works because it works. And our original hookup, we decided to go with the green to brown, brown to green. So that was what the schematic worked out to show should be. It should go yellow to yellow, gray to gray, and then brown and green should reverse. That's what we went with. I turned it on, and in no remote way, shape, or form did the two power supplies synchronize at all. There was no semblance of an attempt. It just flashed like it wasn't connected. So we had discussed this, and so I decided to test the theory that all the wires should go together like colors, and went about reversing the brown and the green so that they went green to green, brown to brown. See if that was the solution. It's possible that there was an error made while reverse engineering this technology, and maybe light colors went to light colors. It certainly would be more satisfying as far as a design, in my opinion, but it was just a matter of pulling the pins out of the plug to give that a go. And we will, of course, plugging it back in. So we power that on, and there's really not a noticeable difference. It doesn't really change anything. There's no attempt, in my opinion, at synchronization. It's hard to tell from the video, but you know, given a long enough time frame, power supplies of similar types eventually are synchronous for a moment, and then they become asynchronous again. So that's essentially what was happening here. So I watched it for a decent amount of time, and some of that's cut out, but I watched it for a long enough time to ensure that it wasn't any better or worse than the reverse, and ultimately it didn't improve things. So back to the original plan. Again, the original plan being that green would go to brown and brown would go to green, and there's a lot of actual garage electrical engineering that was done by the other individual that helped me here that really strongly indicates that the colors should be crossed. So I went back to what we had talked about, thinking, you know, there's probably another solution here. Let's isolate our variables rather than just changing the plan. So retest with the wires back in the configuration that had been discussed. I still don't think I'm seeing a semblance of a synchronization. What I'm actually looking for is whether or not we're trying to reset. So I started going after the clipping settings. I remembered that one of these, the one that was in the wrong housing, in my opinion, the clipping didn't look like it was in the factory original position. The solder iron mark didn't look like it lined up with the dial. So my theory was that if you ruin the clipping enough, which, you know, the voltage cutoff threshold, that may somehow be influencing the ability of these two to fire in time. They may be so far off that by the time the synchronization phase occurs, that it's just a lost cause. I thought I was seeing some attempt to reset the cycle as I tuned these, so I just continued playing with them, keeping them very close to factory, and taking one just past and one just before. The idea being that maybe they need to be tuned together, which would be silly if they were saying you could buy a shelf dash master and make a deck master, but also these are not new. This is 87, 88 components, so it's possible that the components, which again clipping accounts for, the components had gotten so dried out or so aged that maybe the components had changed. We've seen this happen with power supplies where the components degrade and the clipping needs adjusted, or the components need replaced, but a lot of times you can just adjust the clipping. So I felt like I had the clipping adjusted to a point where, and again you can't see it very well in this video, it's attempting to set a synchronization cycle. I was happy with it enough to go to the factory correct bulbs. which are Micromax strobe bulbs. I decided to go with blue lenses over half and no lenses over the other half, just so I could differentiate the two sides. So with the Micromax in place, it became a little bit more apparent that more tuning was needed. At this point, I wasn't really sure what component failure clipping was accounting for, because on this particular circuit board, clipping doesn't affect speed a whole lot, not like it does on the hybrid board that was demonstrated earlier. Clipping on these particular boards really more is simply power. There's a little neon light on each board that you can see glows, and it should glow for each side of the flash pattern. And so what I started doing was looking at that neon light and watching it. So if it wasn't illuminating, I figured I was underpowered, and if it was staying illuminated, I figured I was overpowered. So I was able to get dialed in, and it was very close to factory. I believe the newer of the two, which was the non-sync, actually needed to be dialed up, and the original needed to be dialed down. And I still have not isolated where the component is that is responsible for the requirement of such precise adjustment. But I don't think this is right as far as needing to be adjusted, because I found out that this system, while it is synchronizing, is incredibly voltage sensitive. So my bench power supply was dialed in very specifically to 13.5 volts. And when I switched to a 13 volt power supply, it required a slight retune, and it shouldn't do that. So there's something going on with the input voltage that is requiring extensive tuning of the clipping, which is still something that's being worked on the project end, is why. The theory going right now is that there's capacitors somewhere that are not doing their job, or a diode that's not fully polarity correct anymore. So components are being tested, and there will be some diodes replaced. I'm sorry, I actually think the capacitors are what we're going to replace first. But it does sync. So after adjustment and tuning, we got it to synchronize. It synchronizes pretty well. If it ever skips a beat, it starts over on the what would be the right hand side. Will fire twice, and it will reset. So here's an example of using the cutoffs, and I'm going to do one cutoff and then both. You should really be able to do both without anything going wrong, but both cutoffs represents a pretty decent voltage change overall, whereas one isn't as much. So when I hit the cutoff from the one that I built, essentially added the components to, it's doing what we want, which is it's cutting off that one, and it's firing the remaining one against the remaining two, which counterintuitively it actually does. Even though that's unbalanced, it does that, and it does that okay. There's one extra flash in there if you're looking really carefully, where it has to reset itself, but it would be at this point what I would call close enough to be factory okay. So I go ahead and add the second cutoff, which should cut off all of the left-hand strobes and just flash the right-hand strobes. That represents a significant voltage change, and everything goes haywire. Although we are keeping time, we're flashing one bulb instead of two, and we're flashing it in single flash. So the timing remains unaltered, but the delivery of the flash is ruined. Then I switch it back to just one cutoff, and it does recover. So this isn't factory behavior. We know that it should be able to be put into two-head mode. We know that it shouldn't need tuned. And we're pretty sure that in this era of these two units that the off-the-shelf one should have already had the components in it, and it didn't. So it makes you ask some questions. But so I remove all the cutoffs, and we recover back into the synchronized pattern, and I'm left asking more questions than I have answers about the system. So where does that leave us? Well, I'm not satisfied. I'm doing continued testing. The person that I partnered with on this project feels the same way. We both feel strongly that while the statement that purchasing a second dash master and just getting the cable would always make this work isn't correct, that adding the components should make it work. And there's a couple errors in this diagram, or at least one, but it shows you where the timing chips are, the 555 timing chips. And so we've had to figure out reverse engineer quite a bit of this. So I'm pretty confident I have the right components put in, but they're being tested. And then the components that are in the devices already are being tested, and some of them replaced. So that's where we're at with this. Not incredibly satisfying. But Whelen does reserve the right to upgrade and improve without prior notice. And they upgraded, improved, and experimented a lot. So there will be an update video. I'll let you know what was wrong. And thanks for sticking this one out. And thanks for watching. Have a good day.